Hey everybody, Mr. Kowalczyk here. Today we're going to do Geometry Unit 8, Lesson 7, Determining Congruence in the Coordinate Plane. So for Standard 13.4, I can use my knowledge of properties and congruence of triangles to solve problems within the coordinate plane. Remember that coordinate plane is going to be our XY axis, where X is the horizontal and Y is the vertical. So we're going to be focused on that for today. Now for the opener, we're going to find the midpoint and distance between 4, -6 and -3, 10. Go ahead and pause the video, see if you can do that on your own. Okay, so hopefully you did that. If you can, if you're able to manage it, remember that with our X and Y axis, we're going to graph these 2 points. So we go over 4 and down -6. So that's approximately 4, -6. And then we go -3 and then up 10. -3, 10. So that's going to be a straight line there, a line segment. So I'll connect those two with my straight edge eraser here. All right, now, if you remember, the best way to do this, or one way to do this, I should say, that we've been teaching you, is to create a horizontal and a vertical that make a right angle and also a right triangle. So what we can do is to determine the midpoint, we can realize that, all right, so if here on the x-axis we're at 4, how far over do we have to travel to get to -3? Well, that's going to be 7. And we're not worried about negative or positive, we're just focused on distance here. And we go from -6 up to 10, that's going to be a difference of 16. So if we wanted to go to the midpoint, we would go over 3.5 and then up 8. So that's going to be the middle of that. So 3.5 or 3.5 and then up 8. Now, another way that we could do that, we could count over 3.5 and up 8 and figure out what our midpoint is. We can also use the midpoint formula, which tells us that we take the x's and divide them by 2, comma, y plus y, and we divide those by 2 also to get the average and a coordinate point. So that would give us the exact point, which is 4 plus, not comma, sorry, -3 over 2, comma, -6 plus 10 over 2. So 4 plus a -3 is going to be 1 over 2, which is just 1/2. And then -6 plus 10 is 4 over 2. So that equals 4 over 2, which reduces to 2. So this point right here is going to be 1/2 on the x-axis, comma, 2 high on the y-axis. All right, cool. So now how do we find the distance from here to here? Well, we're going to use that Pythagorean theorem since we have a right triangle. And then we get c squared, or d squared, which is our distance, equals a squared plus b squared, where this is going to be our a squared, this is going to be our b squared, right? One leg and one leg. So we have c squared equals 16 squared plus 7 squared. All right, c squared is going to equal 256 plus 49. C squared equals, well, let's go ahead and do that, 256 plus 49. 6 plus 9 is 15. That's going to be 0.13, so 305. So then C is equal to the square root of 305. And let's just check on that. And the square root of 305 is going to be about 17.5, which makes sense because it should be the hypotenuse, right? So it's the longest side of the triangle. 17.5 is longer than 16. We're good to go. So distance and midpoint formula, we're going to be using those a lot today in our lesson. All right, let's jump down to our notes here. Now, you're going to be asked to prove triangles on the congruent plane congruent using one of 4 or 5 congruency shortcuts, right? So we've got these here, and we're going to figure out the following. To find congruent sides, well, what are we going to do? Well, we've got horizontal, if they're horizontal or vertical. Right? If they go vertical or horizontal. All you do is you just count their distance. Right? It's easy on the coordinate plane of just 1, 2, 3, 4, 5, or 1, 2, 3, however far they are. So if you have horizontal vertical sides, really, really easy. It's going to be super helpful. Now, if they're diagonal, if they're not horizontal or vertical, like this one, we have a diagonal on the coordinate plane, you just use the Pythagorean theorem, like I just showed you up here. So same kind of thing. If they're diagonal, you use that Pythagorean theorem. You'll find out how long they are, and then you'll be able to know whether or not they're congruent in each of the corresponding sides of the triangle. Now with angles, one way to do it is to look for vertical angles. Remember that vertical angles are always congruent. You know, if we have a triangle and a triangle, these are going to be our vertical angles on either side of that vertex, and they're going to be congruent to each other. So we know that they're going to match up. Now, the other way to think about it is if we have parallel lines. Parallel lines make congruent alternate interior angles. So if we have another set of triangles that looks like this, and we know that these two lines here are parallel, well, we know the alternate interior angles are going to be congruent. So they're on either side of the transversal. This one would be the transversal here. And then these two lines here would also, would also be congruent because they're on alternate interior angles on a different transversal. So if we have those parallel lines, we can find that the angles, those alternate interior angles are going to be congruent. Remember, to find parallel lines, they have to have the same slope. And that's going to mean that the change in y over the change in x, or the rise over run for both of those lines has to be the same. Okay. All right, now the last one down here is right angles. Sometimes we want to prove that we've got right angles. Maybe up here in these two triangles, for example, I'll redraw it. We want to prove that these two angles here are right angles. Maybe we need side angle side or something like that, angle angle side. Well, what we need to do is first check and see, are they vertical? Are the two lines that make them vertical and horizontal? Because if they are, hang on, excuse me. If they are, then we know that this angle is going to be right, because vertical and horizontal lines are perpendicular to each other, and perpendicular makes that right angle. Okay, so that's our first check. Are they vertical and horizontal? If they are, sweet, we're done. If they're not, then we have to have opposite signs and reciprocal fractions for the slopes. Right, remember those. So an example would be if we had like 3/7 for one of the lines, and then the other slope would need to be -7/3. The fraction is flipped over, and this one is positive and this one's negative. If we have slopes like that, then we know we have a right angle. All right, so just a reminder, how do we prove congruent sides, angles, and right angles as we're trying to prove these triangles congruent on the coordinate plane? Okay, let's jump into some practice problems here. So number one on the next page, if triangle DEF, is triangle DEF and ABC congruent? If so, what shortcut? If not, why not? Write a plan. Now the plan is going to be, what shortcut do you think these two triangles might be congruent? Well, when I look at them right away, I see I have a horizontal and a vertical and a horizontal. And then that tells me from the previous page, since I have vertical and horizontal, I know that angle D here and angle A here are going to be congruent. So congruent right angles because they're perpendicular with vertical and horizontal. Therefore, I need to look up here and make sure that angle D is going to correspond to angle A in my congruency statement. Angle D is first, angle A is first. So therefore they do. That's good news. All right, we're getting close. So what I'm going to do, my plan is I'm going to try to say prove by side angle side, because I can count this easily. I know this is a right angle and I can count this easily. Just seems like the easiest way to do it. Now I could do side, 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 but then I would have to do the Pythagorean theorem for these two sides, and counting is easier, especially because I know I have that right angle there. Okay, execute plan. So now I'm going to say angle A is congruent to angle D. I know that, and that's going to be my angle. Check, I got that all taken care of. Okay, getting out of focus here. All right, so the we've got these together. Now we need to solve for our sides. So ED is going to be 1, 2, 3, 4 units. All right, cool. AC is 1, 2, 3, 4 units. Cool, we're getting there. All right, so now ED is congruent to AC. That's a side. Check. Now I've got FD, 1, 2, 3, 4, 5, 6. BA, 1, 2, 3, 4, 5, 6. Fantastic. All right, so FD is congruent to BA. I've got my side. Check. So now triangle, I have to write it just like this up here. Triangle DEF is congruent to triangle ACB by, and it says what shortcut, so I have to write that out, side, angle, side. Fantastic, we're done. All right, let's look at the next one. Number 2. Is DEF congruent to ACB? If so, by what shortcut? If not, why not? Now, for this one, I'm going to think about my plan. It doesn't say write out a plan, but I'm going to think about it here. So like in the last lesson, I'm thinking aloud. What I see is I see 3 diagonal sides. They're not vertical or horizontal, and I can't really tell if they're going to be congruent to each other. So what I'm going to do is I'm going to use my Pythagorean theorem. So my plan is going to be to prove by side, side, side. That's what I'm going to try to do. These are congruent to each other. If all of the sides match up, then I know I'm good. So let's check it out. First thing I'm going to do is I'm going to figure out my right triangles. So I've got this one and that one. That's going to be a 1. This distance is 1. And then 1, 2, 3, 4. This is 4 here. Let's go down here. And if you notice, I'm using a red pen. 1, 2, 3, 4. It's just a little bit easier to see. But then I go up and over. Now I do 1, 2, 3. And 1, 2, 3, 4, 5. So that's 3 by 5. Now I have to do the same thing over here with my Pythagorean theorem to see if it's going to work out. So now I'm going to go down and over. 1, 2, 3, 4. And then 1, 2. Okay, so that's different than this. Let's see what else is going to happen here. 1, 2, 3, and 1. And then I go over. 1, 2, 3, 4, 5. And down 1, 2, 3. All right, now it's not looking like it is congruent, but let's just test it out with the Pythagorean theorem to make sure. I know that EF is probably going to be congruent to BC because they're both 5 by 3s. So then EF is congruent to BC. And I can show that because the square root of 3 squared plus 5 squared, right, our Pythagorean theorem, is equal to the square root of 3 squared plus 5 squared, which is the distance of my legs for this particular right triangle and this particular right triangle. All right, now, if one of the other 2 legs is not congruent to each other, the corresponding one, then I can prove that they're not congruent. So let's go ahead. So then we'll say ED is equal to the square root of 1 squared plus 4 squared, which is equal to the square root of 17. And then what corresponds to ED? Well, AC. So AC is here, and that's a 3 by 1. Is equal to the square root of 1 squared plus 3 squared, which is equal to the square root of 10. Now these 2 are not equal to each other. Therefore, triangle DEF is not congruent to triangle ACB. So as soon as we find that one of the corresponding sides, DF and AC, are not congruent to each other, then we know that the 2 triangles aren't congruent. All right, hope this was helpful. We'll do the rest of the problems in class. Adios.